Hello, this is Mr. Best. Welcome to Chapter 6, questions 99 to 104. Question 99. Make a conjecture about what R is for the following scatter plot. Make a conjecture about what the least squared regression line equation might be. So we're taking a look at the scatter plot. We have shoe size and pairs of shoes owned. So you can see that there's not really a whole lot of association between the shoe size that someone has and the number of pairs that are owned. So what conjecture can we make about what R is for the scatter plot? I think we can say that R is going to be approximately 0 for that scatter plot. And to make a conjecture about the least squared regression line, well, if the R value is 0, then your least squared regression line is probably going to be horizontal. And in terms of where that data falls, there's a lot of data kind of right here in between the, below the 4, and then you got some points above it. So if you kind of maybe average those out, it might be, right around 4. It might be a little bit below 4, somewhere in there though. So I think for the least squared regression line, we can say it's approximately y equals maybe a little bit below 4. We'll go with 3.8. And once again, that's because your slope is 0 of a horizontal line, so y equals 0x plus 3.8 if you include the slope of 0. So it doesn't have to be exactly that in terms of what you put, but it would be close to whatever that horizontal line is for sure, though. Question 100. Here are some more news headlines from real observational studies. Just as you did in problem 6-83, determine at least one plausible lurking variable that could explain the cause and effect. Remember, do not argue about the link expressed in the headline. Accept the association or link as true. Your task is to find the other variable or variables that could be the actual cause. So, first one is teens with own cars more likely to crash. So, teens with their own cars are more likely to crash. So we're going to take that as a true statement, and we need to identify some lurking variables that actually could be the cause. So if teens own their own cars, then that probably means that they are able to drive a little bit more often, and due to the extra time on the road, that could be the cause of why they're in more crashes, just simply more time on the road. B, bottled water linked to healthier babies. So once again, we assume that association or link is true. And so what we could maybe say is if people are buying bottled water, maybe the families can afford the expensive bottled water, so therefore maybe they have better nutrition, better health care, things like that potentially. So there's B, and that's it for question 100. Question 101. Solve the system of equation below using any method. Be sure to check your solution. So we're solving for U and V. We have substitution and elimination, and not really set up for either one of them, but we can set it up for either method. If we want to solve by using substitution, I would choose this variable because it has a coefficient of 1, and so we could easily just add the 10 to the other side, and that would give us 2v, I got to be careful with my v's and u's, 2v plus 10 is equal to u, and so that could be used for substitution, or if you wanted to, this one also could be easily subtract the u, and you'd get negative u plus 2v equals negative 10, and that would line up with the first equation for elimination. So either one is perfectly fine, and if you have a different way, that's fine as well. So I'm going to go ahead and do the one I set up first, which is my substitution. So I'm going to take this and substitute it into my first equation for the variable that I solved for, which was u. So 5 times 2v plus 10 plus 6v equals 2. I can then distribute the 5, combine like terms, and also subtract the 50 to the other side. So 16v is equal to 48, negative 48. And if I divide by 16, v is equal to negative 3. And then to find u, I can plug that back into this equation. 2 times negative 3 plus 10 is equal to u, so negative 6 plus 10 is equal to u, or 4 is equal to u. So in terms of solving the system, I have v equals negative 3 and u is equal to 4. So if I want to check my solution, then I'm going to plug both of these back into the original two equations. So 5 times 4 plus 6 times negative 3 is equal to 2. 20 minus 18. 20 minus 18 is 2. So it checks for the first one. Now we'll go ahead and plug it into the second one. 2 times v, which is negative 3, is equal to u. Well, that'll be replaced with a 4 minus 10. So negative 6 is equal to negative 6 is true. And so it does look like we solved the system correctly. Question 102. Find the equation of the line with a slope of negative 4/3 that passes through the point 12, negative 4. So once again, being able to write an equation, given some information. So we know the slope. The only thing we don't have is the y-intercept. So we can use our equation, y equals mx plus b, and plug in all the values that we know. So we have a point and a slope. Y is negative 4. Your slope is negative 4/3 times x of 12, and then plus b. So negative 4/3 times 12. Remember, 12 is a fraction. It's 12 over 1, so you could either multiply straight across, or you can cancel. So 3 goes into 3 once, 3 goes into 12 4 times. So therefore that leaves me with negative 16. So this is negative 16 plus b. Add 16 to the other side, and we get 12 is equal to b. So our equation is y equals the slope of negative 4/3 times x plus 12. And so there's the equation with the slope of negative 4/3 and goes to the point 12, negative 4. Question 103. If the function f of x is equal to the absolute value of x minus 3 plus 5, find each of the following values. And the x minus 3 is inside the grouping symbol absolute value. So we are going to answer these three questions. First, question A wants to know if the input, or x, is negative 1, what's the output? So we're just going to plug in negative 1 for x, and then we're going to simplify. So the absolute value is a grouping symbol. You must do what's inside the absolute value first. And so we get the absolute value of negative 4, which is 4. 4 plus 5 is 9. So f of negative 1 is equal to 9. You should write that whole thing. Part B says f of the cube root of negative 27. And so we want to plug that in, but as looking at that, what is the cube root of negative 20? So we got to go back a little bit to think about this. Square root means what times itself 2 times. This means what times itself 3 times would give you a negative 27. So what number times itself 3 times would give you a negative 27? And you can just think about it. You know, if you do 2 times 2 times 2, or negative 2 times negative 2 times negative 2, that would be negative 8, so it's not large enough. So if we do negative 3 times negative 3 times negative 3, that will be negative 27. So we can actually simplify this to, instead of using the cube root of negative 27, it simplifies to negative 3. And now we can plug negative 3 into the absolute value, so negative 3 minus 3 plus 5. That way it makes it a little bit easier to simplify this from the beginning, and the absolute value of negative 6 is 6. 6 plus 5 is 11. Now, I do want to write this one the same way that it was written originally, which was the cube root of negative 27, even though it could have been simplified. Alright, and the last one, C. So C is a little different. It does say x, find x if f of x equals 10. So since it's telling you what f of x is, wherever f of x is, you're going to replace with 10. Not the x, but the f of x, which is your output. So 10 is equal to the absolute value of x minus 3 plus 5. And so we have to isolate the absolute value. And so we get 5 equals the absolute value of x minus 3. And on this one, you could kind of just think about what values of x could you plug in. Remember, absolute value is a distance, so you should be getting 2 solutions. The other thing that we did do is we kind of just asked ourselves, if we cover this up here, okay, and we say what numbers can we plug in there? Well, 5 and -5 will both give you the absolute value or distance of 5. And so that's how we set it up, is we could say x minus 3, well, that could equal 5, or x minus 3 could equal -5. And now you actually can solve them algebraically. This one, like I said, is not too bad, but if it was, 2x minus 3 or some other thing with decimals, you might have a little bit more harder time guessing what they are. But on this one, if you add 3 to both sides on the second equation, you get -2. So you get two solutions. X is equal to, and since there are two solutions, I'm going to write it in as a set. X equals, that's the curly bracket, -2 comma 8. And so those are the two solutions for part C. And the last one, 104, this problem is a checkpoint for multiplying polynomials and solving equations with parentheses. It will be referred to as checkpoint 6b. So remember, the checkpoints in this part of the textbook is really saying that we should have a pretty good grasp on doing these 4 problems. So in parts A and B, we want to rewrite the expression without parentheses. So we'll start there. And this, on part A, is a monomial times a binomial. So we can use the distributive property. So 2x times x plus 3, simplified without the parentheses, would be 2x squared, and then 2x times 3 is 6x. And so we can't do anything else with that. You could set up the generic rectangle. You only have one side length of 2x, and then up here would be x plus 3. So you definitely could do that as well. Part B, same thing, but this one is a binomial times a binomial. So when we multiply that, we're going to have to do 2 terms in terms of distributing. So it would be 3x times x, which is 3x squared. 3x times -3, -9x. 2 times x, 2x, and 2 times -3, -6. And then you can see that we can combine our like terms. So 3x squared minus 7x minus 6. If you choose to do the generic rectangle again, that is perfectly fine. You'll set it up. You have a 3x plus 2 and an x minus 3. And then you can multiply. And as I said before, you get exactly the same thing. It just gives you a little bit more of a visual as to where these numbers are actually coming from. All right, we're going to move on to part C. Now on this one, it says in part C and D, we want to just solve the equation. So A and B, you are simplifying an expression, and C and D, you're solving. So we have 4y minus 2 times 6 minus y is equal to 6. So we have to be careful. We are going to use the distributive property again, but we are distributing a negative number. So -2 times 6 is -12. -2 times -y is positive 2y. Combine your like terms. Add 12 to the other side. And then divide by 6. So y is equal to 3. And then on the last one, we have D. Got a couple of things. We got kind of parts A and B thrown into an equation. So we're going to distribute the x on the first one. And then on the second one, it's a binomial times a binomial. So we're going to do either the generic rectangle or use the distributive property. So in the first one, we're just going to distribute the x. That's 2x squared minus 4x. And then on the second one, we have 2x squared minus 4x plus 1x minus 2. Alright, and so from there we can combine our like terms on the right side. So that'll be 2x squared minus 3x minus 2. We can then subtract the x squareds, or in this case the 2x squareds, and they do cancel, so all we're left with is -4x is equal to -3x minus 2. Get the variables on the same side. We're going to add 3x. That'll give us -x equals -2. Divide by 1, and x is equal to 2. And so that is the checkpoint for 6b. And once again, these are the things that we should really at this point in the curriculum, have a pretty good grasp of, and be able to solve on our own.